Hello students, I am Dhanurja, lecturer in Civil Engineering, JHARSUGUDA Engineering School, JHARSUGUDA. So today in this class we are going to discuss about bending of beams. Let us first discuss what is meant by a beam. As you can see in the blackboard, that is, beam may be defined as a horizontal structural member which is designed to carry the vertical loads coming from the slabs and to safely transfer it to the adjacent columns. So all of you must be knowing that the loads coming from the slab will be transferred through the beams and it will be transferred to the adjacent columns. So the primary function of a beam is to carry the load coming from the slab and to safely transfer it to the adjacent columns. And a beam will always fail due to bending only. So it may also be defined as the horizontal structural member which fails due to bending only. That is, a beam will always fail due to bending only. And the primary function of the beam is to carry the vertical loads coming from the slab and to safely transfer it to the adjacent columns. So let us discuss about it through a picture. In this figure, all of you can see a simply supported beam. So this is the simply supported beam which we have drawn in the blackboard. And this simply supported beam means one edge is hinge support and another support is your roller support. So when external load, a uniformly distributed load is acting on this beam is getting bent into the shape of an arc of a circle. So on application of the external load, the beam will bend something like this. And if you will draw the free body diagram of the beam through a section XX, and we will draw the free body diagram. From the free body diagram, we can clearly see that due to the application of this external load, a support reaction will be developed at the support and shear force will be developed at the section and bending moment will be also developed at the section. And due to the application of this shear force, due to the development of this shear force, shear stress will be generated in the beam, and due to this application of this bending moment, bending stress will be generated in the beam. So in this particular chapter, we are going to discuss about how to calculate this bending stress. Okay, so all of you see in this figure, when external load is acting on this beam is getting bent in the shape as shown in figure, which is drawn in the red color. Okay, so all of you can see the top fiber of this beam. The top fiber is under compression and the bottom fiber of the beam is getting tension. That is, the length of the fiber is decreasing at the top fiber, and at the bottom fiber the length of the fiber is getting increased. That means the top fiber is under compression and the bottom fiber is under tension. So can we say that from top fiber is under compression and bottom fiber is under tension? That means while coming from top to the bottom, the beam is changing from the top fiber is under compression and bottom fiber is under tension. That means, can we say that from compression to tension it is getting changed? That means if we are denoting compression with a negative symbol and tension is getting with a positive symbol, can we say that from negative to positive it is getting changed? From negative at top to positive at bottom it is getting changed. That means, can we say that in between this compression zone and in between the tension zone, there will be a layer where there will be no change in the length of the member, and that layer of the beam is known as your neutral layer, and the axis which will be passing through the neutral layer, that layer is known as your neutral axis. So due to application of this shear force, due to the development of this shear force, shear stress is generated in the beam, and due to the development of bending moment, bending stress is generated in this beam. So in this particular chapter, we are going to discuss about how to calculate this bending stress. So this is the expression with the help of which we will find out the bending stress. So bending stress is calculated by the equation E by R is equal to M by I is equal to F by Y. And this equation is known as your bending equation or flexure equation. Similarly, the shear stress acting on this beam will be denoted by the shear stress is always denoted with the symbol tau, and tau may be calculated with the formula that is equal to FA Y bar divided by IB. And how this formula is derived, we will discuss it about in the next chapter. But in this particular chapter we are going to discuss about how this equation is derived and how to use this formula. So this is the expression with the help of which we will calculate the value of the bending stress. And this bending stress will be calculated with the help of bending equation. Bending is also known as your flexure. So this equation is also known as your flexure equation. So flexure equation is given by this expression: E by R is equal to M by I is equal to F by Y, where E stands for the Young's modulus of elasticity of the beam, and R stands for the radius of curvature, M stands for the moment of resistance or bending moment, I stands for the moment of inertia, F stands for the bending stress. This bending stress is denoted with the symbol F, or it may be denoted with the symbol sigma. Okay, so F is the bending stress or sigma is the bending stress, and Y is nothing but the distance from the neutral axis. Y is nothing but the distance from neutral axis. So with the help of this equation only, we will find out the bending stress developed in a beam. Okay, so this equation can also be remembered with a simple trick, that is E by R is equal to M by I is equal to F by Y. We can remember this with a trick, that is Elizabeth Rani, may I follow you. Elizabeth Rani, E by R is equal to may I follow you. E by R is equal to M by I is equal to F by Y. So in the next class we are going to derive this expression and we will calculate the bending stress, and how to utilize this formula to calculate the bending stress we will discuss it in the next class. Thank you.